In this video, I want to go over solving a rational equation that will simplify to a quadratic equation. Okay, so here we are given equations where, specifically with these rational equations, we're given one where we have a variable in the denominator, and specifically we're given ones that have a binomial in the denominator. Okay, so let's go ahead and see if we can solve one of these equations. Okay, so here we're given -2 over x plus 1 is equal to -6 plus 3 over x plus 2. So since we're given this here, let's go ahead and copy this. That way we can do some manipulation and keep our original problem. And I'm going to go ahead and move this next one because I think we're going to need the space. Okay, so well, the first thing we ought to do is our goal here really is to see if we can eliminate the denominators entirely on both sides. Okay, so we have to do this in a way that preserves the fact that we have variables and is all mathematically correct. So again, what we've used before in these situations is the fact that we can do anything we want to an equation as long as we do it to both sides. So here, what we can do in these situations is we can take advantage of the least common multiple property here, okay, of these two denominators, okay? So we can actually multiply both sides of this equation by our two denominators multiplied together. So our two denominators in this problem that might give us an issue are x plus 1 and x plus 2, okay? So let's go ahead and multiply both sides by x plus 1 times x plus 2. Let's do the same thing here. X plus 1 times x plus 2. All right. Now, so in doing this, what we'll see pretty quickly is we're now able to eliminate our denominator. So on the left-hand side here, we can actually just kind of get rid of these parentheses here. And what's going to happen is this x plus 1 and this x plus 1 are going to cancel. So the left-hand side here is going to be equal to x plus 2 times -2. Let's actually flip the sides on that so that it's easier to read. We have -2 times x plus 2. Now on the right-hand side here, let's go ahead and distribute this x plus 1 and this x plus 2. So here we're going to distribute this whole thing here first to the -6. So we'll have -6 times x plus 1 times x plus 2. And then we'll have this plus 3 times x plus 1 times x plus 2. We did that because we distributed this whole thing also to this 3 over x plus 2. And this will be over x plus 2. But what we'll notice is these x plus 2's will cancel. And so now what we actually have is -2 times x plus 2 is equal to -6 times x plus 1 times x plus 2 plus 3 times x plus 1. Okay, and now what we can do is we can do all of our distributions and foiling and all of that so that we can try and simplify this as much as possible. So on the left-hand side, let's distribute this -2 now to the x and to the positive 2. So we'll have -2x minus 4. And here, let's go ahead and FOIL these two binomials out. So we'll have -6 times, we'll have x times x is x squared. Then we'll have x times 2, so we'll have plus 2x. Then we'll have 1 times x, so plus x. And then we'll have 1 times 2, will just be 2. Okay, and that's all in parentheses. Then we'll have, here we can distribute this 3 to the x and to the 1. So we'll have plus 3x plus 3. Okay, so now what we can do is we can distribute this -6. Let's do arrows here for our steps. So we'll leave the negative 2x minus 4 over here for now. And we'll have, once we distribute this negative 6 to the x squared, the 2x, the x, and the 2, we'll have negative 6x squared minus 12x minus 6x minus 12. Then we'll have plus 3x plus 3. Okay, so on the right-hand side, let's go ahead and combine all of our like terms. So we'll have minus 6x squared. That's the only one with an x squared, so we'll leave that alone. So negative 6x squared. Then we'll have minus 12x minus 6x. Okay, so that'll be minus 18x, but we have this plus 3x here. So really it'll be minus 15x. Okay, and so then we'll have minus 12 plus 3. So this will really just be minus 9. Okay, now let's go ahead and bring this whole thing, since these are all negative, let's go ahead and bring all of these over to the other side. So we can add 6x squared, we can add 15x, and we can add 9. And we'll get 6x squared plus 13x plus 5. Okay? And that's going to be equal to 0. So now, it looks like, I'm just guessing here, probably our best bet on this particular one would be to go ahead and use the quadratic formula. So we have 6x squared plus 13x plus 5 is equal to 0. I can't immediately see a simpler way to solve this, so let's go ahead and use our quadratic formula. So remember, our quadratic formula is given by x, space this off here, x is equal to negative b plus or minus the square root of b squared minus 4ac, and this is all going to be over 2a. All right, so here we're going to be given x is equal to negative b, so in this case it'll be negative 13 plus or minus the square root of b squared, so in this case 13 squared, which is 169, minus 4 times a is 6 times c is, which is 5. And this is all going to be over 2a, or 2 times 6. Okay, so this will become negative 13 plus or minus the square root of 169 minus 4 times 6 times 5, which is 120. So 169 minus 120, which is 49. And this is all going to be over 12. That's nice because the square root of 49 is just 7. So we have negative 13 plus or minus 7 all over 12. Okay, and this should simplify actually quite nicely. So we're going to move this down a little bit further. So if we have negative 13 plus 7 over 12, okay, this is actually going to simplify to negative 6 over 12. Or really, actually, we just get negative 1/2. Okay? And then if we have x equals negative 13 minus 7 over 12, we just get negative 20 over 12. Okay? And this would actually just simplify to be like 10 over, so it'd be really 5 over 3. Yeah. So we have negative 20 over 12, which would simplify to negative 5 over 3. So there we go. Our two solutions are x equals negative 1/2 or x equals negative 5/3. Okay, so now let's go ahead and try another example. Here we're given 4 plus 5 over w minus 4 is equal to negative 3 over w minus 3. All right, so again, on this one, we're going to want to multiply both sides by our two denominators multiplied together. And it didn't end up being an issue in the last one, but I probably should have said up front, we should double check what our excluded solutions are. So let's do that real quick. Excluded. Okay. So we know that w minus 4 can't be 0. So that means w cannot be equal to 4, because if we have 4 minus 4, that'd be 0. And then w minus 3 also can't be equal to 0. So that means that w equals 3 cannot be a solution as well. Okay, so if we work this whole thing out and we get to one of these is 4 or 3, then we know that we have a problem, because that has to be an excluded solution. Okay, so let's go ahead and copy this so we can manipulate it as needed. Okay, so now what we'll do is we'll multiply both sides of this equation by w minus 4 times w minus 3. Okay, so to do this, I guess we can look at the left-hand side first. Let's distribute w minus 4 times w minus 3 to the 4 and then to the 5 over w minus 4. So this will become 4 times w minus 4 times w minus 3 plus 5 times w minus 4 times w minus 3 all over w minus 4. On the right-hand side here, we'll have negative 3 times w minus 4 times w minus 3. Okay, and this will be over w minus 3. So this w minus 4, these two w minus 4s will cancel, and these two w minus 3s will cancel. And now we're left with 4 times w minus 4 times w minus 3 plus 5 times w minus 3 is equal to negative 3 times w minus 4. And now we can try and simplify. Let's do that. So here we should go ahead and FOIL these two binomials first, okay? So we're going to end up with 4. I trust that you guys know how to do this now. So we'll have 4 times w squared minus 3w minus 4w. So we'll have minus 7w. And then we'll have negative 4 times a negative 3. That's going to be plus 12. Okay. You can do all of those steps yourself if you'd like. You should end up with w squared minus 7w plus 12. Okay. And then we'll have plus 5w minus 15 after you distribute this 5 here. And this is going to be equal to negative 3w plus 12 after you distribute this negative 3. So now let's go ahead and distribute this 4. So we'll get 4w squared minus 28w plus 48 plus 5w minus 15 is equal to negative 3w plus 12. So let's go ahead and move the plus 3w and the plus 12 over to this side here. And we'll end up with 4w squared minus 28w plus 48 plus 5w minus 15 plus 3w plus 12 is equal to 0. And now we combine all of our like terms. So we get 4w squared, and then we have minus 28w, then we add 5w, okay, then we have plus 3w, and we should end up with minus 20w. I think that's it. Okay, and then we have 48, then we have minus 15, and then we have plus 12, and we'll end up with 45. And that should be equal to 0. Now, I think probably our best bet here, again, is to go ahead and use the quadratic formula. So we'll have x is equal to negative b, so negative 20, plus or minus the square root of b squared, so 20 squared, which is, or negative 20 squared, which is 400, minus 4 times a, which is 4, times c, which is 45, all over 2 times 4. All right, so we'll end up with 20 plus or minus the square root of 400 minus 4 times 4 is 16. It's 45, 720. Should we have complex solutions here? I'm wondering if I made a mistake somewhere. Let me take a look here. See, it's okay. Sorry, don't mind the cuckoo clock. I'm working from home today, and there's a cuckoo clock in our living room. I'm not sure if you can hear that or not, but let's take a look here. Okay, I must have made a mistake somewhere here. So we had 48 minus 15 plus 12. Oh, I should have taken the 12 away. Let's back up here. Okay, so this is something that is good to see. Everybody makes mistakes from time to time when it comes to this stuff. I was guessing we shouldn't have ended up with complex numbers, so that means I must have made a mistake somewhere back here. So let's go back. So here we have the mistake I made here was right here. I added 12 to both sides when really I should have taken away 12 here. So this should be a minus 12. Okay, should be a minus 12. And therefore this should have been a minus 12. So really what we'll end up with once we simplify everything, I'm sorry about that, we have 4w squared minus, so now we have minus 28w. Looks like that looked fine. Everything there looked fine. So we'll end up with minus 20w still. But now we'll have 48 minus 15 minus 12. Okay? And now we'll have plus 21 instead. Is equal to 0. That's going to look better. Okay, so hopefully the lesson to be learned here is that it's okay to make a mistake. If you think the problem is going in a direction that doesn't make any sense, go back and double check your work. Like I made a mistake here. There's no one here to point it out to me, so sometimes that tends to happen. But if you think it's going in a direction that doesn't make any sense, there's no shame in going back and double checking your work and making sure you didn't make any mistakes. Here I did make a mistake. That's okay. Okay, so now we have 4w squared minus 20w plus 21 is equal to 0. So now we can use the quadratic formula still. Okay? I'm trying to think if there's an easier way to do this actually. Now let's just do the quadratic formula. Okay, so here we have x is equal to negative b. So again, negative 20 plus or minus the square root of b squared. So we said that was 400 minus 4 times a, which is 4, times c, which is 21. And this is all going to be over 2a, or 2 times 4. So simplifying this, we get 20 plus or minus the square root of 400 minus 4 times 4 times 21, which is 336. So 400 minus 336 is 64, all over 8. So we'll end up with 20 plus or minus, so the square root of 64 is 8, and this will be over 8. So we have x is equal to 20 plus 8 over 8, which is just 28 over 8. And we can divide both of these by 4. So we'll end up with 7 over 2 here. And we also get that x is equal to 20 minus 8 over 8. In this case, we get 12 over 8, which just simplifies to 3 over 2. So our final answer is 7 over 2 or 3 over 2, and that didn't conflict with any of our excluded values, so we know that these are 2 possible solutions.